You have made it to another end of a module. Aren't you excited? All right, so video 16.1, we're going to kind of review the stuff that we did for lines. I know you just can't wait to review. All right, so 16.1 is review. All right, let me kind of zoom in here. I think y'all can see that. All right, so first question, name a plane parallel to plane WXT. All right, remember how you do the planes. Here's W, here's X, here's T. So it's this rectangle right here, who would be parallel to plane WXT, would be this one in the back. So I'm going to pick any three letters. I'm just going to go plane ZYU. Okay, we're good. Okay, stay with me. Name two segments parallel to segment VU. Well, look, VU is right here. Okay, parallel is in the same plane, so VU is parallel to ST. Doesn't matter that ST is longer. And then probably the one you thought of right away, look, VU is parallel to ZY. Okay, take a look. Yes, there can be more answers. Someone said WX, and yes, WX would also be parallel. Okay, name two segments parallel to SW, segment SW. Here's segment SW right here. So parallel, you could say TX. Parallel to SW, you could say VZ. Okay, and I'm sure there's more answers. Okay, all right, can you name me two segments skew to XY? Remember my favorite word, skew. All right, so XY is right here. Okay, all right, I want skew, so not in the same plane but not intersecting. All right, so not in the same plane. I heard someone say SW. Good, look, SW is running north-south. XY is running diagonally but in a different plane, so SW is good. All right, is there any other examples? What's that? ST? All right, let's see. ST is right here. All right, and XY was here. Very, very good. Remember, they're running in different directions but not in the same plane. All right, finally, can you name me two segments skew to VZ? All right, where's my VZ at? All right, here's V, here's Z. All right, see how that one's running up and down? Look, this one's running side by side in the front, so I'll put ST. Okay, you could also say WX. Okay, and again, we were looking at VZ. VZ's right here. All right, so that's parallel planes, parallel lines, and skew. Excellent. All right, now let's get to the fun ones. Yeah. Do you remember the problems where the lines were parallel and there's a transversal? All right, so let's do that. And I'm gonna go ahead and zoom, make that diagram larger, and we can come back to that if we need to, but I don't think we'll need to. All right, it says line A is parallel line B. It says that angle 2 is 63 degrees, so I'll put that baby right here. All right, and the measure of angle 9 is 105, so I'll put that right here. And I don't know about you guys, but I would do vertical angles right away. And I'm hoping that y'all can see, look, so you see how there's a line right here and a line right here. So 2 and 5 are definitely vertical, okay? 2 and 5 are definitely vertical, so you can put 63 degrees here. Okay, everybody's cool? All right, angle 9 and angle 7 are vertical, so you can put 105 here. Okay, 7 and 6 are on the same side. See how the parallel lines are here, so these are consecutive interiors, so these will add up to 180, so then this one's 75 degrees. Okay, all right, and then, I don't know if we've talked about linear triple, but look, 6, 5, and 4, those three angles come together and make a straight edge. So this has to add up to 180. So you can go ahead and add the 75 degrees plus 63 degrees, and then subtract that from 180, and that will give you that 42 degrees right here. All right, good job. All right, and then, so see the 42 degrees, angle 4, and angle 11 are alternate interiors, so this is also 42. Okay, angle 8 has to be equal to angle 6, so 8, I'm just going to put it down here. Measure of angle 8 is 75 degrees. Only because I can't fit it in there. Okay, where else can we go? If 11 is 42, then 13 is 42, so the vertical angles. Look, 11 and 12 are a linear pair, so you can go 180 minus 42, and you get 138. And that makes angle 14 is vertical, so also 138. All right, take a look, take a moment, how are we doing? All right, and then finally, angle 3 right here. Okay, angle 3 would match up with that 75. See how it's the same two lines? It makes 3 and 6, so it's vertical angle, so it's 75 degrees. And if angle 4 is 42, then look, that's vertical angles, and that's 42 degrees there. Okay, fun, all those angle relationships. All right, okay, let's try one more problem, and then I'm gonna shut up. I know, it's a miracle. All right, one more with these parallel lines. All right, let's try this number 13. I believe it's parallel lines. Yes, you can't see the instructions, but it actually says that L is parallel to M. So I'm going to write that here. L is parallel to M. Okay, and look, these are consecutive exteriors. Okay, so consecutive exteriors are also going to be congruent. Okay, so you're going to go 10x minus 17 equals 8x plus 1. Okay, you guys remember what consecutive exterior angles are? Do you remember how basically it's one's on the left, one's on the right, okay, right? This angle here is to the left and above, and then this one's to the right and below. And so those are definitely exterior angles, but they're alternate angles. They're always going to be congruent. All right, I'm going to subtract I'm going somewhere with my story here, and I'm also not on screen. Lord. All right, let's subtract that 8x from both sides. That really just wasn't a very good explanation, was it? All right, let me unzoom a little bit. Okay, so these four are exterior angles, but this one's on the left and this one's on the right, so they're alternate exteriors and they're always congruent. That's what I was trying to say, Lord. All right, 2x add 17 to both sides is 18, divide by 2, x is 9. Woohoo! All right, x is 9. So I'm going to take this expression right here, okay, and I'm going to go 8 times 9 plus 1. All right, 8 times 9 plus 1, which is going to give me that 72 plus 1, which is 73 degrees. This angle here is 73 degrees. All right, these two angles are a linear pair. So if I go 180 minus 73, this is 107. I'm going to take this expression and set it equal. So 6y plus 29 has to equal to 107. We're going to subtract 29 from that. So here we go. 107 minus the 29 gives me 78. Okay, stay with me, stay with me, stay with me. And then I'm going to go divided by 6, and I get y is 13. All right, man, I am still not on that screen. So let me make sure we're good here. All right, if this angle here was 73, okay, let me unzoom a little bit more. If this angle is 73, then these two add up to 180. 180 minus 73 is 107. Take the 107, set it equal to that expression. I did that right here. Subtract 29, divide by 6, and y equals